Hello friend, in this particular video I will be talking about Haar Cascade classifier for detecting multiple faces in a single image, like what you can see right over here. Currently I'm using the same piece of code snippet which I have shown in the previous video. I have changed the file from people1, I just came to people2.apg. Let me execute the code and we will see that it will detect multiple faces from a single image, and that's what it is showing. But over here you will find some of the false positive area detected where the algorithm is thinking that over here the face is there, but in reality no such face exists. So we have to modify our code, we have to add some filtering parameters so this particular false positive gets rid of. So currently what I will do is that first I will add one filter over here that is called minNeighbors. So this particular filter will help us to do something great. I will, after doing some trial and error, I found that if I add over here the minNeighbors value 7, it really works well, and as I execute the code you will find that the false positive area will not be there anymore. See, it's not there anymore. So what this particular filter parameter is doing, that what I will explain to you through graphically. So let me open this small image over here. Just imagine this is the area, this is the portion of the image which you saw just now. Over here the Haar Cascade classifier is creating one you can say it's like a box of 4 by 4 pixel width, and this box will scan from the top left corner to the extreme right edge. It would go on and then it will come down and it will scan all the segment of the image to find out that the object of interest, which is the face right now, is that available in the picture or not. Now while the scanning will be going on, this is one box, but will there be only one box? No, because the minNeighbor I have said it's 7. So that means there will be parallel boxes that would come over here. So suppose this is another box that comes up over here, and there would be one more box that will come over here. So that means this is how the number of multiple boxes generated. So minNeighbor 7 means there would be 7 such boxes that would scan each row, and while it is scanning, definitely something will happen over here is there would be some overlapping area, which is quite obvious because as this box move ahead, certain portion of this box will be overlapping with this box, and as this moves ahead, then there will be some overlapping area which this box will be encountering. And this overlapping is very important because what we saw is when the minNeighbor was not there, some false positive area were detected. But with the addition of this particular filter, now what is happening is all these overlapping areas, they have to identify that this is a face, or this is an identity of the identification of the object that what we're looking forward, that what it has to acknowledge. So when all these boxes says that yes, this is the same object what we're looking forward, then only that object will be marked as identified. And when this any one of the boxes say no, this I don't think that this is not the object, then it would not turn up. And that's what we saw just now as we added this minNeighbor value. The area of positive which was showing over initially has been read off. That means these boxes, when they did the scanning, they find out one of the boxes may have written a negative value while the other boxes may have written the positive value. Since the negative value was there, because of that reason that area was not detected. Hence we land up with these faces, although couple of faces was not been figured out. That's fine, not an issue, but no such false positive area is actually present over here. Okay, so that's how this particular filter parameter is working. We can add over here one more parameter, and that is called mean size. So what is this mean size all about? That also I will show you. It will take a tuple as a value. Suppose I say that if the value is 40 comma 40, that means by width and by height it should be 40, minimum 40 by width and 40 by height, and that's what I'm printing over here. So if I print the value over here, width and height, then this will show me that the object of identification, what is the width and what is their height respectively, that will come over here. See, 49, 49, that means 49 is the width, 49 is the height. Suppose 52 is the width, 52 is the height, 49 again, 50, 51. In that way it has said it. And I have set the mean value to be 40, 40. So that means all the images that would have the minimum of this width, minimum of this height will be considered over here. And that's how this thing is working. But suppose if intentionally I make it 50-50, in that case certain images will not be there because these 40 will not fall under the mean value. Hence only those images or those objects that are having the width above this, then will be treated over here. And as you can see, this object has gone, this object is no more. In fact now see, there is no value of width 4040 is there actually. So that's how this is working. So this is one of the way of filterization, you can say. So let me change the value back to 4040, and that would be good enough as far as our image is concerned. Okay, now addition, one more thing I would like to tell you, this particular parameter, I mean this particular reference which is holding this entire matrix, you can say. So because we are going through looping of this matrix, so I can see that I can utilize this matrix to find out what is the length, or I can say how many figures or how many faces it has detected in the image. That we can do it very easily, and for that reason we will just go for a length of this, and we will find out the number of faces detected. Although I know that a couple of faces was not there in the canvas, but still this can be a good enough, okay, because advanced algorithms are there where we will get through this particular problem. Nonetheless, we have been able to figure out the multiple images from a single multiple faces rather from a single image, and for that reason we are using this particular to filter parameter, which will help us to get rid of some unwanted areas and to find out the exact number of faces that exist in the image. Okay, so that's all from this video presentation. I hope you understood the mean neighbor concept, and this is going to play a very important role in the object detection in context to Haar Cascade classifier. Okay, see you soon in my next video. Until then, have a nice time. Bye bye.